I'm asking that you send anything you want to work on to learning at mathbymatthew.com. It's the best way for me to organize it for this lesson. I'm sorry you weren't able to
Where,
connect.
sorry?
I'm sharing my screen. You should see it on my screen. Let me know. Let me know. I mean, I'm sharing the screen that you should see where to send what to work on today.
Learning at Matthew by Matthew. Learning math by Matthew.
Learning at math.by.matthew. Yeah, you can send it there. And you can always send that ahead of time before the lesson starts. So in the booking email you receive, it'll say, you know, send anything you want to work on here. So as soon as you send that, we can start looking at it.
Okay. Okay, I sent one of them. I just have like 2 more to attach.
Okay, that's fine. All right, so I see some pictures coming through.
Okay.
All right. So do you want to work through all of these? I see, I don't know, did it start at 1 or does it start at 4?
Oh wait.
I'm seeing it starting at 4.
Oh yeah, it does start at 4. Sorry, we're doing the even page only. Okay.
So let me snip in the first question, and then we can talk about it. Okay. Do you see question 4 on your screen?
Yes.
Okay. How many planes are shown in the figure? So you know that there's a point. There is a line segment. It's a line segment like AB. We'll call that point A. This is a line segment. And then there's also what's called a line, which we often use interchangeably with line segment, but it's not completely correct. This is line here, AB. And then there's a plane. So a plane has sort of this sheet of paper. Okay, so you're basically looking for anything that looks like a flat surface. So I'm gonna create a list here. Like I see the front, the back, So the front is this area. The back is I don't know, I'll call it this area I'm shading behind there. There's the right side, the left side, there's the bottom, and there's the top.
Mm-hmm.
Is that okay?
Yeah.
And then what's not clear to me is this one on the outline, is it included? Well, it kind of is, but it's the same as the one defined by M or S, M, and R. Like
Mm-hmm.
they're the same plane. So like here's a plane, and then there's one because they extend out infinitely in each direction. So these actually keep extending out.
Oh, okay.
So I believe the answer is 6. I would ask you to confirm that with the instructor here. Now the next question. So let me snip in. It's now asking for collinear points. So let me paste, and then let's get a little more room here. Let me grab the actual question. Do a new snip. Oops. Cancel. New snip. Okay, so it says name 3 collinear points is the question.
Mm-hmm.
So that means they have to be on, that means, and this is the definition, they have to be on the same line. So we know that a line is infinitely extended in each direction. It can't sort of be disjointed, like there's a point and then there's another point over there. Like if that's A, B, and C, these are not collinear. So I mean, do you think it'll be multiple choice on your quiz?
I'm not sure. She hasn't told us yet.
Okay, because the really the way this would be asked is like, give me, give me 3 collinear points. Well, like M,
Mm-hmm.
X, and S are collinear,
Yeah.
and I mean there it is. It's right there because they're on the same line here.
Yeah.
Okay, like let's say I'm gonna add a point up here. Let me call that Z. Then Q, comma Z, comma and P are collinear. Is that clear?
Yeah.
Okay. And let me just remind you, I am recording this and I'll share that video with you. It probably will be ready later today
Okay.
for you to look at. It takes a while to process. And then there's one final question here. So let me actually go and grab this. Oh, I can't grab the picture again. I got to grab the figure every time. Let me grab that. And it's kind of like a which of the following is true type of question here. Let's grab this one. And then it says are points N, R, S, and W, are they coplanar? Do you see that question there?
Yeah.
N, R, S, and W. So we first got to find them. I mean, there's N, there's R, there's S, and there's W. W is kind of on the corner.
Yeah.
So if we replaced it, if we had N, comma R, comma S, and M, they're all on the same sort of like trapezoidal sheet.
Mm-hmm.
N, R, S, like they're flat. Like if we were doing this in person, I would show you a piece of paper that these could all fit on. The problem is W is kind of like it's up above my screen. It's really hard to. It's like this point W is up high here. It's like imagine there's a table, and this table represents a plane. Well, there's a point that's up here that's not on the table. And that's what W is. W is not on the table.
Oh, okay.
It's not on the plane. This is very visual, so if it's not clear, um, let me know. But we'll answer this question. So N, R, and S, they lie in a plane. That's true. Plane A. So A is a cursive letter that's used to denote denote a plane. So you can use one letter. But W does not. So W is up here. It's not in the plane. So I'm pretty sure A is correct. Let's look through. Let's look at B. N, R, and W line in plane A. Nope. It's N, R, and S. N, R, and S. They're on this table, like on a sheet of paper. And then so no, and then N, R, S, and W. We already said no. Okay. So the only one that might be considered is like, can you get a plane through 4 points? So the answer is that if I give you a plane like this, all the points have to be on that sheet of paper. So you can have 4 points on a plane, but they have to all be on the sheet of paper.
Okay.
So as soon as and the truth is, you actually only need 3 points for plane. Because and here's the reason why. If I give you two points here, you can only draw one line segment between them.
Mm-hmm.
If I give you 3 points that are on a line, you can only draw one line segment that goes through all of them. But as soon as I move the points, like this point and this point, as soon as I put one off here, the only thing that can connect them all is some sort of a plane.
Okay.
So that 4th point has to be on the same sheet, or if it's up, if your 4th point is over here, it's not on the plane.
Okay.
And just a reminder with this format, if anything is really unclear, just tell me and I'll try my best to explain it differently. I'll definitely do that. So
Okay.
question 7 here. Moving on to that here. Let me snip that and bring it in. Here's question 7. Okay, so we're trying to find the length of this line segment E to F. You can count these. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16. So that 16 tells you the fraction, because we know it's 1 and then something. So you just count however many lines there are between the two big numbers, and you put that number here on the bottom.
Mm-hmm.
Then obviously you figure out, where does this one fall? It falls at 11. So that's how you come up with this one here. Let me make another segment here. Let me call it EG. And I hope it's big enough for you to see. I know you can zoom in here on Zoom. Could you give me the length of EG?
EG.
It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16. So there's no number that goes out in front. Like, you could put a 0. I mean, they don't put these on rulers, but it's 0 right there. The number that goes in the bottom is 16. And then see how it touches at 10?
Yes.
So we wouldn't put the 0, but we would say 10 over 16, and that's 5 over 8 when it's reduced.
Mm-hmm.
All right, so I am not seeing questions 8 through 12.
Oh, it's just the even pages that she wanted us to do.
Okay. I would just say maybe your instructor is saying, "Oh, don't only do those because I'm going to test you on the other ones." So just keep that in mind. We can always do those other ones if needed.
Okay.
All right, so here is the next question. I'm going to snip that and put it on the screen here. Okay, 13 is line segment GF, line segment FE. Like I remember sometimes they even ask you to write this out in words like line segment GF, something like that. There's some instructions. There's probably some instructions above this, meaning our G to F, which is here, and F to E, which is here. I don't know. The question says yes or no. Maybe it's asking if they're the same.
Yeah, because there's nothing above that.
Okay, you've got the document. There's no instructions above that. There's nothing on the previous page.
Oh, it says find the measurement of each segment. Assume that each figure is not drawn to scale.
Okay. The only thing that we know for sure is that G to F is the same as H to E. G to F is congruent to H to E.
Mm-hmm.
And we also know that this top one, G to H, this G to H up here, it's the same as FT because there's the two lines and the two lines. So you're looking for the two lines that are like two lines means these are the same, and then the single line means that that those segments on the left are the same. So all we know is that GH, which is 5x, is congruent to FE, which is also 5x. And then over here, this is 6x. It's congruent to 6x. But what they're trying to do is have you compare these two, which one's a single line, one's a double line. I mean, the answer is no. They're not the same because one is 5x and one is 6x.
Mm-hmm.
5x is not the same as 6x. Normally you give a value. Like sometimes it's okay. Let's say x is 1. Well, that means that this top is 5 and this is 6 and this is 5 and this is 6. Is G to F the same as F to E? And the answer is
No.
no. No, they're not. So I think that's what it's asking for. Not completely sure, but that's kind of what it's looking for. So 14 is asking for to find each measure. Okay, measure. There's an important distinction in this class where sometimes you're asked to find the measure of something, and measure means the length. When you have a ruler, you are measuring,
Mm-hmm.
and you have to remember that really means to give me a value. Like this almost always means give me the number. Give me the number.
Mm-hmm.
So V to W is this distance here, and this is 5 and this is 1, and you can always do a right minus left,
Mm-hmm.
which means 5 minus 1, which is 4. The measure is always positive.
Mm-hmm.
Always positive. So this is ridiculous. Like you don't get -4, but you could. I mean, you could somehow rationalize that as being correct, but the measure itself is always positive. It's kind of like how long is the room? How big is the package? It's all a number.
Mm-hmm.
Anything unclear about that?
No.
Okay, I'm gonna go to 15. All right, so it says Jorge used the figure below to make a pattern for a mosaic he plans to inlay on a table. Name all of the congruent segments in the figure. All right, so the first thing is see where there's a single line. You can say that F to E is congruent to B to C. So this
Mm-hmm.
symbol right here means congruent. Have you seen
Yes.
that in your class? Now,
Yeah.
now it does not matter. Like I could have said, and there's a lot of other ways. I could have said E to F. E to F is congruent to B to C. Like the order of the pairs doesn't matter of the letters.
Mm-hmm.
I could have said E to F is congruent to C to B. And you might be hearing me say that. I keep saying F to E. And I know in the class they'll just say FE, but I liken it to I'm starting from someplace and I'm going to another.
Yeah.
It's the path. I think of it as a path, and that way you know where you started and where you ended.
Mm-hmm.
And I find that to be more clear when I'm explaining this and learning it. So FE is congruent to BC. So that's the first type of congruency. The second type of congruency are the double lines. So you got like F to A is congruent to A to B. And that's congruent to C to D. And that's congruent to D to E. And you can write the statement this way. This is a statement of congruence. And it can be written in this manner where you just go out horizontally as far as you need to.
Okay.
Oh, I didn't even realize that this was multiple choice. I apologize. So BC, so it looks like C is correct. And then D is correct.
Okay.
This is a multiple choice. I guess that was the intention of the instructor. Okay. Did you send more than one email? Because we're coming up to the end of this first set of pictures that you sent me.
Um.
Like we've only got another 2 problems.
Yeah. Some of the photos are loading in the other one.
Okay. All right. Well, send that off as soon as as it finishes. I've got 20 next as the one to look at. Is that? So let me grab that one here. I recall looking at this with you last time we met, vertexes, and this is all completely new and different. It's geometry is just a different thing altogether. So there's 2 ways to label angles. You can label angles with a number. Angles can be labeled with just a number. So in this case, angle 5, it refers to this angle right there. It can also be a single letter. So a single letter works sometimes, but not all the times, and the most common is to use 3 letters. And the 3 letters always have the vertex. The vertex is the middle letter, as the middle letter. So the example would be, okay, angle M. Angle M could refer to this angle that's sort of down, this angle that we just grabbed, or something else. But with 3 letters, we can say angle N to M to O. Start at N, go to M, come back to O. So that middle letter, this middle letter is always the vertex. So I'm going to ask you a couple of questions here because I want to make sure that you can do this. Let's say I asked for angle 6. First of all, what is the vertex? What is the vertex of that? What's the letter of angle 6?
Angle 6.
What's the vertex letter?
Is angle 6 the one you highlighted, right?
No, angle 6 is up here.
Okay. That would be letter N.
Letter N, right? And then if we wanted to use 3 letters, we know that that's the middle one. So we could go O to N to M, or we could go angle M to N to O. But in both cases, N is right in the middle. N is the vertex. Okay, so I want you to look at angle 1, and I want you to give me 3 letters that define angle 1.
O, P, and M.
Angle O to P to M. Good. So that does work. So would angle MPO. So notice again, all I did was switch these letters, the first and the last. You switch the first and the last. Okay, let's go to the next question. 21 says angle N to M to P. N to M to P. Sorry about that. There's a dog barking here.
Okay.
Angle N to M to P. What is it asking here for? Oh, the vertex of each angle. Okay, so we've kind of already covered that. I mean, it's the middle letter. It's the middle letter. Middle letter is always the vertex. So that does kind of end. That does end the questions here. That we could maybe do the next one because it just asks for the midpoint.
Yeah. The rest of my questions are like halfway done. Do you want me to like send them to you over text or something?
It's really best for me to do it through email.
Oh, okay.
I'm trying to get away from having them come through that. It just
Okay.
So this question looks like it's asking for the midpoint of R to T, segment RT. So that's here. And I don't know what the answers are, but S is right in the middle because it has the same distance from each endpoint. So I don't know if it's asking for that position, like the position of the midpoint is 1, but it's also at point S. I think sometimes they use that for S or the point.
Yeah, okay. Okay, they finished, so I just sent it.
Okay, I will check that out here. I'll remind you here that I'm doing a virtual homework help tomorrow night at 7. So if you need some additional questions answered, or if you want me to explain another concept, I'm going to do that tomorrow. So you just got to sign up. It's totally free, and might be good to do. Okay, the email did come in, so it looks like we've got some more of the same questions. 25 is the first one that came in. Is that okay to start there? Julia, does that work for you?
Yeah, that's fine.
Okay. I'm going to snip that in and we can take a look at it. Okay, so 25 says, actually I didn't grab the instructions, but I believe it says to probably to determine, actually, well, there are no instructions. I'll write another name for each angle. So angle Q to P to R. So it's this. It's not a triangle, but it's part of it. Looks like an angle there. So there's a bunch of different ones. Obviously, angle 3 is good. Angle 3 is that angle. The reason it's not angle 2 or angle 1 is because the number has to be on the interior of the angle. Now there are other possibilities. The Q to P to R could also be R to P to Q. It could also be R to P to Q. That's where you just swap the first and the last letter. But I'm not seeing that there. All right, so now the next question, 26 says, find the coordinates of the midpoint of a segment with the given endpoints. Okay, so we're finally getting into some numerical problems. The midpoint has a formula. It's also something you've done before, which is finding the average of,
Mm-hmm.
of two numbers. So
Mm-hmm.
the midpoint is like an average. And there's a formula, you've probably seen this, like x1 plus x2 over 2, comma, y1 plus y2 over 2, where this first number is x1, the second number is y1, x2, and y2. You can absolutely use this formula for the midpoint, but an average is something you already know how to do. If I said to find the average of -12 and -8, you already know to add them and then divide by 2 because there's two numbers. So this is -20 over 2, which is -10. So we can see already from just the x value that that one is correct. But let's do the y value. We know the y values are -7 and -4. So you add them up and you divide by 2. So that's -11 divided by 2, which is -5.5. Are there a few more questions on midpoints? Because I usually give a couple of other questions about them. Well, we do have quite a bit more to get through, so maybe I'll just keep going here. Oh, and just for future notes, you can always download this document, this Google Doc as a Word doc, and
Mm-hmm.
or PDF um, through Google Docs. Like there's a on the top there's like a save as, and you could just send this to me next time. Would also be
Okay.
just fine.
Yeah.
So name an angle or pair of angles that satisfies each condition. So two obtuse vertical angles. So vertical angles means that they are congruent and they share a vertex.
Mm-hmm.
Okay, so it's like this angle. This is an obtuse angle because it's more than 90, and you can just do that visually. And then if I take this one from the left here or from the right, and I just extend it, and I extend this one here, so this angle right here, 1 and angle 2, they are congruent and vertical because they share the vertex. They're also obtuse, but angle 3 and angle 4 are not.
Mm-hmm.
I'm sorry, one and 2 are, but angle 3 and 4 are not. 3 comma 4 are not. They're actually acute and congruent. So we're just going to look at these one by one. G to F to H. G to F to H. That one looks obtuse to me. Looks kind of like
Yeah.
what I made there. C to F to E. See how C, F, and H are collinear, and G, F, and E are collinear. That means that
Mm-hmm.
this angle right here and this angle right here, they're congruent and vertical. So those actually do work. So we got lucky. I don't know how else to say it. Like G to F to C, G to F to C. That one's an acute angle. This one, I don't know if you're able to track that in real time, but uh, these other ones here, these are acute because they look
Mm-hmm.
like they're less than 90.
Yeah.
B, C, D, that one's also acute. This one right in here looks also acute.
Mm-hmm.
G, F, H, and CBA. So they give you GFH again, but then they give you CBA. CBA is, I don't know, it's they're not congruent. So these last ones, they're both obtuse, but they're not congruent because they don't share that vertex.
Mm-hmm.
Not congruent. Okay, so the next thing, okay, 31. I'm glad 31 is one that we're doing, because this is the question that I wanted to make sure we did as well. So let me paste this one into here. So I'm going to actually make a quick graph here. So -3, -8. Actually, let me start it. Let me start up here. -1, -2, -3, and then -1, 2, 3, 4, 5, 6, 7, 8. So -3, -8 is down here. And 1 comma -2 is down here. This is 1 comma -2. So if E is the midpoint, okay, here's D and here's E. If E is the midpoint, that means that this line extends here, and then it extends up somewhere in this region. Do you agree with that? Do you follow how that F is somewhere up here? Like you start at D, E is the midpoint. You go up and over to get to this point. Well, you go up and over the same amount to get to that new point. Julie, are you still with me? Julia, are you able to hear me? I'm not sure you're getting this. Hello? Hey, Julia, are you there with me?
Yeah, I just got disconnected for a second.
Okay. Let me know when you can see my screen again. I had plotted points D and E.
I can see your screen.
Okay. I was trying to explain that F is somewhere up. F is somewhere in this sort of region. Like it's you started at D, you go up some amount, you go right some amount, and you can do the same thing to get to F. Like if you draw another one of these triangles, like here I went up 1, 2, 3, 4, 5, 6. So if I go up 1, 2, 3, 4, 5, 6, and then I go right 4, 1, 2, 3, 4, there's F. Like I go up and right the same amount. Do you follow that?
Yeah.
Okay, but there's another way. There's actually a better way, and it's to look at the ordered pair here. The ordered pair, 1 comma -2, and I call this a jump. Like how much did you jump to go from -3 to 1? How much did you go up? And the answer is 4. You're going,
Mm-hmm.
and then how much do you go up to go to -8 to -2? You went up 6. So that means to get to the end point, you're going to go up another amount. You're going to go up 4 again. So -3 to 1 is 4. 1 to 5 is another 4. You went from -8 to -2. That was 6. -2 to 4 is another jump of 6.
Mm-hmm.
I'm just going to guess that wasn't exactly clear. So I'm going to try that again, if that's okay.
Okay.
So it's like this. Let me give you a point, 3 comma -2 comma -1 comma 4. Okay. So this is the midpoint, and you're trying to find the endpoint.
Mm-hmm.
What is the jump to go from 3 to -1? How did that happen? Like what did you go up or down?
You go down 4.
Down 4. So we would say, so to go down another 4 would be -5. This is down 4. So this one is down 4. To go from -2 to 4, you're going up 6. So this one, you're going to go up 6 again. So that's 10.
Yes.
So I call these jumps, and that's kind of the way I would think through it. There's also another question where they actually ask you to go backwards that I sometimes see on these quizzes. So I mean, it's up to you if you want us to do that. Let me know. Because we just did a jump forward. We did like going to the right. And sometimes they ask you to go to the left with these questions. Or should we keep going through the questions on here?
Could we please keep going through the questions?
Okay. 36 I can't do because it refers to something else.
36.
Yeah, like I'm looking at 36 is the next picture that I got, but it says name an angle adjacent and supplementary to DCB, but it's referring to a picture. Maybe it's referring back to the picture that I showed earlier. I mean, that's one of the issues with not having the document is I can't tell you what it's referring to, but we can go off of that. So I'm going to paste that, and then I'm going to grab the.
Oh yeah, that's the one it wants.
Okay, I'm going to grab 36. This actually is, it's, believe it or not, it's faster than doing it in person because I can just snip on the computer here and I don't have to redraw it. So name an angle that is adjacent. Adjacent means next to. Okay, so it can't be something, and so we got to find D to C to B. So D to C to B is right there. Okay, supplementary means that it adds up to 180. And that might be like, well, how am I supposed to know that? Well, 180 is a straight line. So do you see something that's a straight line? Like for example, there's several options here. Like if do you see how D, C, and G are on the same line?
Yeah.
So there's another angle B to C to G. This one and this one, those are supplementary. And actually, that one B, C, G, it's not given. So then there's also this one over here, FCD. FCD, which is also makes a supplementary going this way. But I'm not seeing the one that they want. So let me just look at them again. GCF, that is not it. D to C, oh, D to C to H is. See how it's that one that goes there. Let me grab the picture again because I do think. I don't know. Maybe let me try it. Let me try it again with the picture because I don't know if it's clear. All right, pasting that in. So we have angle. That's not very large. D, DC, B. So this angle right here, and then D to C to H is this one right here. Do you see how B, comma C, comma H are on a straight line? So that's how you know that they are supplementary.
Okay.
All right. So we've got a new figure here. And let's grab that. Ooh, I know what the issue is. Okay. All right. So we got in the figure. Measure of angle DCE is 4x plus 15. So this one right here, D to CTE is 4x plus 15.
Mm-hmm.
And the measure of angle E to C to F, E to C to F, that one right there is 6x minus 5. Okay, it wants us to find the measure of angle D to CD. So this first one. So we need to know the value of x, which we don't know. But we know that CB and CD are opposite rays. Okay, but CE bisects DCF. This ray right here bisects. That means that these two are congruent.
Okay.
So that means we can just set them equal. We can say, okay, well, 4x plus 15 equals 6x minus 5. I mentioned this before, but there's kind of like two things that you end up doing. You either set things equal
Mm-hmm.
or they add up to something. In this case, sometimes they add up to 180 or 90 or another number, but in this case, you're going to set them equal. So can you solve this for x for me? Solve for x, please.
X equals 10.
X equals 10. That's right. But and see how that's an answer there? That's not what it asked for. It didn't say to find X. It said to find the measure of angle D to C to E. D to C to E is 4x plus 15, which means you put in 4 times 10 plus 15, which is 75 degrees.
Okay.
So we are coming really close to the end of our lesson time here. Let me pick either 38 or 39. I'll do one more and then we'll have to stop. And like I said, you can get the other questions answered tomorrow night if you want to do the virtual homework help.
Okay.
Do you have a preference here for 38 or 39?
Can we do 30, please?
30?
Yeah.
I don't see 30 on this, on anything you sent, so I can't do that. Oh, I see. Name 2 obtuse vertical lines. I thought we already did that. I thought we did that up. We did that up here. It's letter A.
Oh, okay. Did you say 30 or?
Yeah, 38 or 39.
Oh, okay. I thought you said 38. I thought you said 38
No,
or
38 or 39. I'm just
okay.
gonna grab. I'll just grab 38 here because I do have to move on to another lesson. I
Yeah.
can't. But let me jump in here and do this one for you. The time goes so quick. Okay, 2 angles are complementary. That means they add up to 90. So that's what I meant by like sometimes they set them equal, sometimes they add up to something. The measure of one angle is 21 more than twice the measure of the other. So the first angle is x, okay?
Mm-hmm.
The other angle is 21 more than twice the measure of the other one. So that's this part becomes that. But we know that they add up together to be 90. This is angle 1 and this is angle 2.
Mm-hmm.
Okay, so we're gonna just solve here. So we get 3x plus 21 equals 90. We're gonna subtract 21 from both sides. We get 3x equals 69, x equals 23 degrees. So that's the first angle. If we take 2 times 23 and add 21 to it, this is 46 plus 21, which is 67 degrees,
Mm-hmm.
just where I get there. So in 39, it's gonna ask their supplement. That means that they two things add up to 180.
Mm-hmm.